Welcome back to the channel. Today we're diving deeper into the core operations of digital computer systems, register transfer and memory transfer. These concepts form the backbone of how the data moves within a computer. Let's start with register transfer. In digital computers, registers are denoted by capital letters, sometimes followed by numerals. For instance, the memory address register is called MAR, the program counter is PC, IR stands for the instruction register, processor registers may be labeled as R1, R2 and so on. When we transfer data from one register to another, we use a symbolic replacement operator. For example, the following operations means that the content of R1 is copied to R2. Importantly, the source register R1 remains unchanged. What if we want this transfer to happen only under a specific condition? In that case, we use a control signal like if P equals to 1, then the content of R1 is copied to R2. Here, P is a control signal generated by the control section of the computer. We can also simplify this notation using the following control function. This separates the control condition from the operation, making it cleaner and easier to read. Sometimes multiple microoperations are required under the same condition. In such case, they are separated by using commas as shown in the example below. This means that both transfer happen simultaneously when the condition T is met. Every statement written in register transfer notation implies an underlying hardware construction. This highlights the direct relationship between the notation and implementation. Now let's move to memory transfer. Consider a memory that interacts with two main registers. The address register AR holds the address of the memory location. The data register DR temporarily holds the data being transferred. A read operation transfers data from memory to the data register or DR. Symbolically, it is represented as follows. Here, MAR is the memory location addressed by the address register and its content is moved to the data register. In contrast, a write operation sends data from a register to memory. The symbolic representation is provided here. This means that the data in R1 is written into the memory location addressed by the AR or address register. To summarize, the register transfer involves moving data between registers, optionally controlled by conditions, and memory transfers deals with moving data between registers and memory through read and write operation. Understanding these operations is essential for anyone studying digital computer systems or computer architecture. If you found this explanation helpful, give this video a thumbs up, subscribe to the channel and hit the bell icon for updates on more digital system concepts. Drop your question in the comments below. Thanks for watching and I'll see you in the next video.